Here's another review problem in force, work, and energy. We have a 3-block system and it's being raised upward against gravity. We have a 156 Newton force pulling upward, and this is one of those multi-body problems. And you remember, with a multi-body problem, you need to choose the system to suit your needs. Why don't we first consider the system to be all of these masses? And if the system is all of those masses, then let's do a Newton's second law procedure on them. There would be 156 newtons pulling up, and then here we have m times g. And we do that in our head, what would m times g be? M is going to be 12 and g is 10, so that's going to be 120 newtons, isn't it? So Newton's second law says that the net force should equal the mass times the acceleration. The net force is going to be 156 minus 120, and that should equal 12 times the acceleration. What's that going to be? 36 divided by 12, 3 meters per second squared. Now, that wasn't a question that was asked. We're wanting to know what the tension in this upper and lower rope is going to be, but this, I think, is going to help us figure that out. Now that we know that all of these are accelerating at 3 meters per second squared, why don't we say, you know what, let's make the system just the 4 kilogram mass. And if we draw a free body diagram for that, we'd have m times g for the 4 kilogram mass only would be 40 newtons. And then we have this tension in the lower rope. I'll call it T sub L. So let's do Newton's second law with that. T sub L, take away 40, is equal to the mass times the acceleration. We already found that. So what does this come out to? 12 plus 40, 52. All right, that was the lower rope. Well, let's try and find the upper rope now. How should we do that? Any number of ways you could do it. We could say, you know what, let's make the system the 3 plus the 4 kilograms. In other words, we're going to consider this whole thing to be the system. Now, when we do that, this tension in the lower rope is an internal force. So the tension in the lower rope we cannot consider here. If we draw a free body diagram for this case, there's our 7 kilogram mass. What's mg on a 7 kilogram mass? Isn't it 70? 7 times 10. And then we have the tension in the upper rope that is going to be accelerating this. So let's write out a Newton's second law here, and then I think we'll be done. Tension in the upper rope minus 70 is equal to the mass of the system that we're considering, which is 7. And we found at the outset that that system would be accelerating at 3 meters per second squared. 21 plus 70, 91.